So I'm going to try and define the basic tempered Frobenioid. So basic tempered Frobenioids. So we're going to start with a X to be a Berkovich space. And then what we're going to do is we're going to take pi. This is going to be the tempered fundamental group. Group of X. And so I'm going to pick a base point. So Machizuki does a lot of work to get rid of base points, and I'm not sure if I should be taking it or not. Anyway, so this is going to be the tempered fundamental group, and then this is going to be the base category for our basic tempered Frobenioids, and this is going to be so you take the G sets of this guy. And then you take the connected components, and this is the same thing as the category of tempered covers of X. All right, and so now that we have this kind of base, we're going to define a model category, or sorry, a model Frobenioid, and so to do this you need divisors, principal divisors, and some divisor map. To do this, I'm gonna kind of take a basic version. So let's do the baby version. Oh, so the baby version of the divisor monoid for tempered Frobenioids. So here's what we do. So we need to take a tempered cover, a tempered covering. Okay, so we'll take a tempered cover, and to this tempered cover we need to associate a monoid. Okay, so here's the baby version. So we'll start with S to Y. This is going to be a finite étale Galois covering. So this is a covering of Berkovich spaces. Okay. Then we take the universal topological cover. So this is the universal topological cover. Then we're going to take a formal model. So this is a formal model of the universal topological cover. So these are now formal schemes. So this was all done over a local field, and so these are with respect to so they're going to be over spoof of OK, where K is the local field here, and yeah, and then they're going to be the completion with respect to the maximal ideal there. Okay, so we take the formal models, and then we take the effective divisors. Take the effective divisors. On this guy, so we take the effective divisors on this gentleman. Okay, and then finally we take Galois invariance. Finally, we take Galois invariance. So this means that we take here, so S infinity, here, and then we take the S infinity over Y. And so this was defined in the video for the tempered fundamental group. Okay, so these steps, so let's count them. 1, 2, 3, 4, 5, 6, Okay, so these 6 steps kind of give the baby version of the divisor, divisor monoid. So what we're going to fix now is we're going to fix this part here, so where we choose this covering. So to fix this, so the full version is the following. So what we're going to do is we're going to take a pro system. So this is going to be a pro system of finite et al. Galois coverings. Okay, and then so what we'll do is now I'm going to tell you what the monoid is. Take phi x temp. This is the basic monoid for tempered Frobenioids, and to this tempered cover. Okay, what we're going to do is we're going to take this limit. So this is going to be a co-limit, and we're going to do these effective divisors on this model here, and then we're going to take the Galois, so that should be that. So let me make sure I put, okay, yeah, we're good. Okay, so then we take these Galois invariants. Again, this was defined before. So this is the important monoid here. So let me kind of pick a color. Okay, so this will be the monoid for tempered Frobenioids. Okay, so then there's kind of some modifications. So the modifications are, sometimes what we're gonna have is we're gonna have x to be marked. Okay, so it's gonna be a log structure. So then we're gonna ask that these maps be, well, these maps. So okay, we have to do some modification for log structure. Okay. To get the principal divisors, we do the following. So P tempered of x, y, so we take this covering, it's going to be a similar limit here, and then we take meromorphic functions on these guys, so that we take that system again, and then we take the Galois invariance of that. Okay, to get the divisor class map, the divisor map. So we'll take div x temp from phi x temp to p of x temp. We just take the divisor of a meromorphic function. Okay, and this lets us define the basic tempered Frobenioid. So now we can say, here's the definition. So the basic tempered Frobenioid associated to a Berkovich space X X over a local field is the Frobenioid. I'll just call it tempered of X over K. So let's say complete local field So this is going to be the model Frobenioid with all the stuff that I just defined. Div. Okay, so where do we go from here? From here, we got to define, so the next steps are we're going to define, we're going to construct other Frobenioids from these, and then we're going to do the base theoretical. So we need to do, so this kind of base changing. So we'll take some totally epimorphic category, which is connected, and we'll have it have a functor here to these tempered coverings. And then we need to make a notion of a base theoretical. Okay.